from this tutorial. In this video lecture, we will be seeing one more example of convolution of continuous time signals which have infinite duration. The example that I have taken is f of t is equal to e raised to the power minus t ut and h of t is a unit step signal, and the result that we want to obtain is y of t, which is given as f of t convolution h of t. Now let's see how this can be implemented by using the formula for convolution. So the formula of convolution that we have is y of t is equal to minus infinity to infinity f of tau h of t minus tau d tau. Now in this, the first thing that we have to do is we have to change f of t into f of tau. So at the place where we had t, we will now substitute it as tau. So the function then becomes e raised to the power minus tau multiplied with u of tau. Now we know u of tau is a unit step signal which is present only for the values where tau is greater than equal to 0, and the value of that function is 1. So 1 multiplied with this function will be e raised to the power minus tau for tau greater than equal to 0, and it will be 0 for tau less than 0. So this is the value of the function that we get for f of tau. The next function that we want is h of t minus tau. So for this, first we'll have to change h of t into h of tau. Now h of tau is equal to u of tau. Now this u of tau is again a unit step signal which has a value 1 for tau greater than equal to 0, and the value is 0 for tau less than 0. Now what I want to do is I want to apply time reversal and time shifting operation onto this function to obtain this. So when I apply both the things, the function I need is h of t minus tau. So at the place where we had tau, now I am substituting it as t minus tau. So this will be then equal to 1 for tau less than equal to t, and it will be equal to 0 for tau greater than t, and this function is then u of t minus tau. Let's look at these functions now graphically. When I plot the graph of e raised to the power minus tau multiplied with u of tau, the function will be like this, which will have some values only when tau is greater than equal to 0. The next function is h of t minus tau, which is then equal to u of t minus tau. Now t is a variable on the tau axis. This t can have a value which is smaller than 0 or a value which is greater than 0. When it has a value which is smaller than 0, we will have the function only till here, because what we have is the function is present or it has a value 1 only when tau is less than t. So when tau is less than t, the function value is 1. So it will be 1 throughout this t. Next is when tau is greater than equal to 0, we will have the function present here, because this is the value for tau less than t, and it is 1 when tau is less than equal to t. So we will have a waveform that will be of this shape. Now next, to implement this formula, what do we need to do is we need to multiply these two signals. When I multiply this signal and this signal, we will have the result as 0, because they do not have a common place where both the signals exist. When you look at this form, when I multiply this signal with this signal, both the signals are present on the tau axis in a common interval, and that interval is from 0 to t. So we have the multiplication result only when this tau is from 0 to t. So this f of tau h of t minus tau is giving me some result which will be equal to e raised to the power minus tau, because the value of this function is 1 only when t is greater than equal to 0, but with a restriction that the tau value is restricted from 0 to t, and for other values of tau, the function or the multiplication will be equal to 0. When I substitute this into the formula where we have y of t equal to minus infinity to infinity f of tau h of t minus tau, this then becomes, and the range of the integration changes from minus infinity to 0 to t, and the function value is e raised to minus tau d tau, and when I integrate this, the result that I get is 1 minus e raised to the power minus t. So we have the result y of t, which is equal to 1 minus e raised to the power minus t for t greater than equal to 0, and it is 0 for t less than 0. So generally, when we are doing the convolution of continuous time infinite duration signals, what do? Is we substitute the values of those signals into the formula and then try and solve the formula. Thank you for watching this video. I hope it will be useful to you and understanding how the convolution is performed. If you have liked the video, please hit on the like button and subscribe to the channel. Thank you.